Okay, problem number 3, label the 6 trig functions as either odd or even. Explain the significance of this graphically and algebraically. Well, it's fairly straightforward to remember which is which. Draw yourself a little reference unit circle. Think about some positive angle theta, and then also think about some negative angle theta. If you think then about the x and the y values here, this is not to scale. It should be, those should be perfectly symmetrical. But think about sine. So sine of theta has some value, right? It's corresponding to that point right there. We can label that point with, instead of x and y, we could label it with cosine of theta comma sine of theta. And again, that's just because we know that x is cosine and y is sine. And similarly, I could do the same thing down here and say that x is cosine of negative theta, because now we're dealing with the negative theta, and y is sine of negative theta. So I get that right there. Now, think about how these points compare. Think about how the y values compare. Well, this positive y value, that distance from the x-axis, is exactly the same as the distance to the y value of the negative theta. The only difference is that the negative theta has a negative y value because it's below the x-axis. So from that we can state the relationship that sine of, let's change this, we can say that sine of negative theta is equal to the opposite of sine of theta. Sine of negative theta, so this value right there is the opposite of this value right there. That's a true statement. That's what that equality says. Well, that is the definition of an odd function. It's saying f of negative x is equal to negative f of x. That is what an odd function is. Okay, well, let's think about cosine. How do the cosines compare? Well, the cosine is the x value. Both those triangles share that base, therefore their x values are the same, so we can then say that cosine of negative theta equals cosine of positive theta. And again, that is the definition of an even function this time. F of negative theta equals f of positive theta. And so cosine is even. Okay, well, one more to think about. What about tangent? Well, let's do a little algebra for this one. Let's say tan of negative theta equals, using the quotient identity, tan of negative theta equals sine of negative theta over cosine of negative theta, because tan is sine over cosine, but you need to keep the inside of the function the same, so it still has to be negative theta. But think about what we used up here. We know that sine of negative theta is the same as negative sine of theta, so I can pull that negative out, call it negative sine of theta. And we know that cosine of theta is the same as cosine of negative theta. So in the denominator there, cosine of negative theta can become cosine of theta. And what do I have? I have negative sine theta over cosine theta. Well, that's negative tan of theta. And again, that's the definition of an odd function. F of negative x equals f of x, negative f of x, and so cosine is also odd. Well, what about the other ones? If sine is odd, then so is a cosecant. So cosecant is also odd. If cosine is even, so is secant. And finally, if tangent is odd, then so is cotan. So we have these 6 functions identified as odd or even. Let's think about what that means now. So, for sine and tangent and cosecant and cotangent odd functions, what it's saying algebraically is, say we're evaluating sine of, how about negative 5 pi over 6. Sine of negative 5 pi over 6 is going to be equivalent to negative sine of 5 pi over 6. And you could simplify it that way, same as if that was a tangent. Graphically, what it's saying is, if you think about a sine graph, sine looks like that. We'll continue it down this way. What it's saying is we have symmetry across the origin. So if that's some negative x value and that's the same positive x value, they have the same y values. That's what that symmetry means, just like y equals x or y equals x cubed. And then if you think about cosine, well, what this is saying is cosine of, let's use the same example, negative 5 pi over 6 is equivalent to cosine of positive 5 pi over 6. And again, symmetry-wise, we're saying, if you think of the cosine function, it looks like that, but continued this way, it's saying the same thing. We have this symmetry here, where if that's negative x, then that's positive x. Now, instead of having opposite y values, they have the same y values. So this would be like y and negative y, whereas this would be like y and y still. They have that symmetry across the y-axis. And that's that.